You can change colors for multicolor 3D printing in just 5 seconds. The printing process produces zero waste. You can handle multicolor TPU printing. You can print with different types of filaments on the same build plate. This is a machine that's about to kick off the multicolor 3D printing next era. Multicolor 3D printing is a feature that once model enthusiasts try, they can't go back. Whether making toys, products, functional prototypes, or creative live hacks, it offers creators a much richer color palette to work with. However, the downside of traditional multicolor printing and filament swapping were quite obvious. It significantly increased the printing time. Each filament change took 1 or 2 minutes. Changing filament required purging the leftover material from the nozzle first, then loading the new filament. This generated a huge amount of extra waste. So even with multicolor printing capability, in current model design, color application is often limited by the printing method. Designers tend to place different colors on separate layers, sacrificing some visual impact to provide extremely low printing efficiency. But with this machine, the filament change time is cut down to just 5 seconds. By swapping print head, it generates almost no additional waste. This machine will undoubtedly make the workflow much more efficient for model hobbyists and designers. Filament usage is also greatly reduced. It offers incredible value for money. I use it to print multicolor single-body models, interlocking structural models, prints combining soft and hard materials, and single-piece multicolor mobile toys. Several models I really like. I tested it while having fun. So today, I'm going to share a relatively in-depth user experience review of this Snapmaker U1. A more detailed unboxing process can be seen in my previous video. It uses a Core XY structure overall. The enclosure is made of plastic and transparent acrylic with a glass front door, so the device isn't overly heavy. The whole machine weighs 18.2 kilograms. The multicolor feeding module is integrated into the side of the machine body, so the overall footprint during printing is relatively small. It's very suitable for daily use on a desktop. The back only has a transparent panel with no filament exit port, so you can place this printer close to a wall. It only produces a few bits of purge waste when a new spool is first loaded. Therefore, the waste collection system is directly designed as an internal waste tray inside the machine. In my test, with 4 spools, which was loaded and unloaded 7 times, means 28 spool changes in total. The waste produced was only this much. Proportionally, even if you change 28 spools a day, you only need to empty the waste bin once a week or so. Starting basic print tests. First, let's print a first layer to check. 1 dark color, 1 light color. Look, it's quite flat. For the Benchy board test, I directly print 4 boards of different colors on the same plate for a single print. Total print time was 4 hours and 18 minutes. Total filament used was 77.59 grams. If switched to the current mainstream single nozzle color change method, the print time would directly exceed 19 hours. You can also try slicing a 4-color Benchy in your current printer slicer software and compare the print time and material usage. When I did this test during the unboxing, there was a wide string during the print. This time, after switching to a few dry spools, the string is basically gone. This brutal test of 4 colors per layer shows the 4 print heads are very well aligned. The surface is still very smooth and neat. Overhangs are no problem either. In a few spots, the flow rate seems a bit high. Using a tiny bit more filament, with a bit more extrusion flow calibration, it should print even more perfectly, but the current result is already very high quality. The key point is saving several times the printing time compared to similar prints. Next, I tried a single body 5-color model. I set a pause layer in the print process. When printing reaches this layer, the machine automatically pauses, just like a regular filament chain. I load a spool of a different color. Click to resume printing. This way, when it prints the head, it will still use slot number 2, but the filament loaded now is yellow. This little workaround lets you get models with even more colors. Next, increasing the difficulty, I printed a comprehensive test model. It succeeded in one go with default settings. Long travel moves are no problem, with layer heights from 0.2 mm to 0.8 mm. mm. The printed parts have a tolerance about 0.2 mm without issues. They can rotate normally. The super difficult lollipop test also printed successfully. This overhang angle test printed up to 7 degrees without issues. The U1's maximum build value is 270 times 270 times 270 cubic millimeters. I modeled a box of the same size for an ultimate challenge. It required over 800 grams of filament. Halfway through, the filament ran out. It supports power loss recovery, filament ran out recovery, added a new spool, and it could continue printing. Let's draw a line on this layer so we know later where it resumed from. Let's see if there are any issues. At the same time, we printed boxes at their maximum build volume on the Bamboo Lab X1C and the H2D, as these two represent current mainstream desktop and larger format printer sizes. Everything about these lines is from the resumed print after the filament ran out. These two different whites joined together very neatly. You can compare them. This gives you a visual sense of just how large this volume is. It's definitely sufficient for daily creative work. So I tasked it with printing a multicolor model I've always wanted to make, Venom Spider-Man, a 4-color model. The height pushes the U1's limit, a 270mm extreme multicolor test. It can be printed in less than a day. The work was completed perfectly, removing the supports. This model is smoother than Dove chocolate. The U1's color change speed is really super fast. Measured from leaving the model to change color to finishing the change and returning to the purge tower, it's done within 5 seconds. The print head is preheated before being swept in, so after sweeping heads, it can start printing immediately. Now, with these 4 heads constantly heated, does it consume a lot of electricity? We also measure this during the 4-color Benchy print, using a smart meter to record power consumption. The maximum hourly consumption was 0.057 kilowatt-hour. That means printing this kind of 4-color per layer model for 24 hours would use less than 1.4 kilowatt-hour total. That's about the same as an office computer running for a day. Besides faster color changes, each head can also independently use different filaments. Many 3D printing enthusiasts have tried printing their own shoes with TPU, but TPU filament is pretty soft and kinda sticky when 3D printed. It's really tricky to switch filaments back and forth on a single print head. But the U1 can have each head independently handle TPU of different softness, hardness, and colors. You can even reserve one print head specifically for printing PLA supports, making model removal easier. At the TCT 3D printing exhibition, Snapmaker was printing a multicolor TPU shoes live on site, so there's no need to repeat the test here. Today, I'm challenging something even more difficult: PLA+TPU+PETG and PA-12CF, a 4-color 4-material print. This is a high-level difficulty. I wonder if it can handle it. The printing temperatures, softness, hardness, and even required ambient temperatures for these materials are all different. For this, we need to change the nozzle on the U1. The U1's 4 print heads all come standard with hardened steel extruders. The maximum supported printing temperature is 300 degrees Celsius. This allows it to support high-strength engineering filaments. However, the standard nozzle is stainless steel. Printing with high aberration industrial filaments would cause significant wear. You can replace it with a hardened steel nozzle. Let's also look at how to remove and install its nozzle. It has a magnetic rear cover design. Unplug the 2 cables, unscrew the 2 screws, and the nozzle can be removed. Install the new nozzle in the reverse order. You can see inside is all modular. Feature maintenance or part replacement shouldn't be too complicated. Besides PLA, the other 3 filaments I want to print require extreme dryness. Also, TPU and nylon carbon fiber need a shorter, smoother pass directly into the extruder. In this case, you can feed filament directly from the rear of the U1. I directly connected 2 Sanlu drying boxes to the back. This allows for printing while drying. These colors reminded me of the EVA color scheme, so I made a Unit 1 colored folding stand. The material bonding effect exceeded expectations. The 98 TPU is directly embedded into the nylon carbon fiber material, which has strength comparable to metal. PETG and PLA are used as accents. Once 3D printing enthusiasts start using this machine, they just can't stop, continuously printing all sorts of models. The printed parts fit together very well when assembled. The assembly process process is super satisfying. Basically, with it, all those multicolor models I wanted to print before but hesitated due to waste and time, I can now print them all. I expect some netizens might think that supporting only 4 colors is too limiting, but I want to say, for other machines that support more than 4 colors, do you really often use them to print with more colors? When I first got the X1cc, I equipped it with 2 AMS units. At the time, to experience 8 colors, I even thought about going for 16 colors if the results were good. But after printing just one 8-color model, I took the second AMS off. I installed it on a P1S. The width I could actually accept. The main issue was that with the previous color change method, adding one more color multiplied the printing time. This made me simply give up on the idea of using it for more colors. For models with more colors, I resorted to printing in separate parts. Also, when you look for multicolor models on various model websites, it's very hard to find single body models with more than 4 colors, let alone 8 or 16 colors. They are mostly models split into parts. Of course, it's undeniable that the Bamboo Lab AMS started the multicolor 3D printing era 2 years ago. It was a very impressive design, but just 2 years later, I believe the Snapmaker U1 will kick off a multicolor 3D printing next era, precisely because the U1's multicolor printing efficiency has reached a new level. We now have the demand and creative space for more colors. My overall experience is that the U1 allows me to design and create 4 colors and multi-material mixed models with much less hesitation. U1 has been officially launched on Double 12. Its launch price is 4,500 RMB. The price is quite competitive. Of course, I also have more expectation for its future development. For example, since the print heads are already independent, could each head be equipped with its own filament switching system? That way, while one head is printing, the other head in the waiting area could simultaneously perform color changes. Then the number of filament colors would be virtually unlimited. But this is just my greedy wishful thinking. If you have any thoughts about this machine, feel free to leave them in the comment section. I also hope you can give a like, subscribe for support. I will share more fun 3D printing related content. See you in the next video.